Hello, this is Hui. Welcome to watch my video C++ Programming on Linux. In previous two videos, we have discussed and introduced OpenSSL BIO and the EVP interface. We have demonstrated how to use them to encrypt or decrypt message data or files. In this short video, we will discuss another popular topic, OpenSSL EVP Message Digest. EVP Message Digest or hash function takes any arbitrary message data with any content or any length as an input and provide a fixed size of hash value as a result output. EVP Message Digest implement a secure one-way functions which is from original date to secure hash values. From a hash value, there's no indication about original date that produce it. The only way to identify the original date is to brute force through every possible combination of input. Every message digest algorithm has a fixed length of output. For example, SHA-256 algorithm, which is a secure hash algorithm, 256 bits hash value of 32 bytes. MD5 algorithm, the MD5 message digest algorithm, which provide 128 bits hash value, 16 bytes. The SHA-512 secure hash algorithm, 52 bits hash value and 64 bytes. This is currently the longest hash value length. Two distinct input, the probability that both yield the same output is highly unlikely. This is the functionality provided for Message Digest. In this short video, first example, we're going to build a program called EVP Digest Disp, which take algorithm and the message from command line and print the hash value after digested. First, we have to include a header file called evp.h. And we have to declare two pointers. One is called mdctx, is a message digest context pointer. And MD is message digest algorithm. We allocate two memory. One is called MD underscore value, store our hash value after digest. And one called plain text is the original message date. MD underscore line is the hash value length. First, we set up memory, use the memory set, and after we get a usage from command line, and we get the MD, which is the message digest algorithm, use the function get digest by name, and the name is from command line, argument 1. We get the original text from a command line, argument 2, and the text line of argument 2. And we make the memory copy to our plain text of argument 2. After that, we can start our message digest process. First step is to create a message digest context. The function is called evp underscore md underscore ctx underscore news. So return is the md ctx equal. This is the first step. And our second step is to initialize the context by identified algorithm. And this function takes three parameters. First parameter is MD context, MDCTX. Second parameter is the type of message digest, which is MD. Third parameter is the implementation. In this demo, we take a default implementation, so we put a none. Message digest algorithm. We can use it from the function getting by name. We can also directly use it as a function, for example, EVP SHA-256. And this function was defined in the evp.h file. So all this function was defined in the evp.h, which we can use to perform message digest. Now we back to our program. Here we back to MD. The third step is a digest. Function is EVP update. So this function, first parameter is context, empty CTX. Second parameter is pointer of memory where the original data is, which is plain text. Third one is the length of this plain text, which is the text length. Fourth step is finalize, retrieve the digest result value from the CTX to the output buffers. The function called EVP finals EX. First parameter is MD CTX. Second one is output buffer, which is MD value, and the pointer length of this MD, which is MD. Now we finish the digest. We have to clean up, so it's EVP MD. If we don't do the clean up, it's possible to get a memory leakings. Finish the digest, our result is in this memory MD value. This is the length of hash values. So to print them out, we can use BIO dump function. This function, which std out, we print on the screen, and the location will be the MD value, which is const pointer, and the length, which is MD length. In order to make it clear, you can print out this algorithm. The algorithm from AR1 length is and then we finish our program. Now we save this, then we go to our terminal, we compile the program EVP digest this. This is our executable. So our usage will be, first parameter is the algorithm. This take a SHA-256. Second argument is message. Just print this is quick test message. So you can see this is the original date and this is the output, our hash value in HMO format. Length is 32 bytes. If our message is longer, you can see length is the same because this length is dependent on the algorithm we choose. The hash value will be different. If we choose the different algorithm, for example MD5, you can see if MD5, the byte is 16, the hash value is like this. The second example, we're going to build a program called EVP digest file. The argument 1 is the algorithm for message digest. The argument 2 is in date, original date, and argument 3 is the output hash file. We include evp.h. We declare two pointer, MD context and MD. Because we are going to input the output file, so we create two BIO, BIO in and BIO out. We create two memory, MD value and plain text. We memory set our memory before we use. After get from command line, first we centralize BIO in using the BIO new files. Argument 2 is the in file, so we are reading, and the BIO out from argument 3, which is output file, so we writing is binary, and we get the algorithm use MD get digest by name. Name is from argument 1. Similar as the previous example, step 1, create a message digest context, use EVP MD CTX new. And then we initialize our digest empty context using the algorithm we get from the digest by name. We make a loop using BIO read from BIO in into the plain text original data buffer. And after we get a real byte, then we use a digest update to update empty context of this plain text and the in byte. Finish the loop, read every file. We're using the empty digest final to retrieve result from empty CTX to the memory, which called empty value, which is hash value, and empty length of these hash values. We free empty CTX, and we can use BIO write to BIO out of our result hash value, and then we free our BIO in, free our BIO out. Then now we can save our program. We go to our terminal. We compile our program called EVP digest files. So this is our binary. In order to test this program, we need an original data file. So we create a file called test original.txt. In this test, we have 8 lines of transactions. Now we run our program. First argument is the algorithm. So we choose SHA-256. Second is input date, test original.txt. Next one will be the output hash files. And because this is hash original SHA-256.dat. So this is a binary date. You can see this is binary data, which is 32 bytes. In order to see this, we can use SHD. This is the hash value we generated. One of popular use of message digest is to verify original date has been changed or not changed. So now we create third program called message digest verify. So the usage of this message digest verify. Argument 1 is the algorithm we're using to digest. Second argument will be the input data files. Third argument will be input hash files, which is for verify input file has been modified or not modified. First, we still declare the pointer of empty context and empty, which is the algorithm. And we create two BIO, both BIO for input. One is called BIO in, another called BIO hash, which is we load the hash file we generated for verify original data file. And we created 3 memory. One is called empty value, and one is called plain text, and the hash and the score buffer, which is we load from the hash files. And this is a message digest length. When memory set, all this memory buffer. After we get the input from a command line, we get a BIO in from argument 2, which is the input of data files. Argument 3, which is still read, is binary. We call the BIO hash, which is load from the hash data files. We still get empty digest algorithm from function get digest by name, and the name get from a command line argument 1. We create a new message digest context, initialize our empty context by the algorithm that we selected, and then we make a loop read from BIO in, which is input date, into plain text, and we use empty digest update to update our digest context. Finish the loop, we use empty digest final, retrieve the result from empty CTX to empty underscore value, which is the hash value memory buffer and the length of hash values, and we free our empty context. And after that, we read again from the hash value files into hash underscore buffer. Total byte read is the in byte. If in byte is greater than 0 and equal empty length, and we use memory compare MEMCMP empty value buffer and the hash value buffer for empty length. If this is equal 0, so we say verify OK. Either of these verify is not OK. So now we save this file. go to our terminal. We compile our program, EVP underscore digest verify. So now we have original date. We created the hash value file, which we can use this verify. This is original date has been changed or not changed. So first is algorithm 256, second is input text date, and the third one is hash value we originally generated. You can see the verify our file is okay, not modified. Now we try to modify this file. We just change this value from 100 to 900. Then we run verify again. You can see this verify fails. This we can verify the integrity of original data files. We can also use this as original document signatures. We can also use the OpenSSL command line to digest the files. So digest and the digest we call MSHA 256. Output will be binary, and the output will be .dat, and our input will be our original date. So let's run. We try to compare. They are different because original date has been changed. Hello, this is Hui. Thanks to watch my video, which it is useful, and it's going to be great to have your feedback.